Welcome to Sir RP's channel. In this video, you are going to learn how to solve quadratic equations by extracting the square roots. This is second learning competency to be discussed in Mathematics 9. So, learn and love math with Sir RP. We have this most essential learning competency. The learner solves quadratic equations by extracting the square roots, factoring, completing the square, and using the quadratic formula. But for this specific session, we will focus on extracting the square roots. Are you ready to learn? Sit back, relax and get ready to learn. First, I have a question. Please keep this in mind because I will be asking this at the end of this session. How would you know if the given quadratic equation can be solved by extracting the square roots? Reserve your answers for I will ask this again later. For now, let's have a short investigation. What is the square root of 16? Basically, our answer is 4. But, what is 4 times 4? It's 16. Right? -4 times -4 is also 16. Right? Thus, we can say that square root of 16 is positive and -4. Let's try another. What is the square root of 25? Basically, our answer is 5. But, what is 5 times 5? It's 25. Right? -5 times -5 is also 25. Right? Thus, we can say that square root of 25 is positive and -5. How about square root of 0? The answer is 0. Why? It's because 0 times 0 is 0. So, square root of 0 is also 0. Then, what is square root of -4? Is there a number when multiplied by itself will give a negative product? I think we have the same answer in mind. The answer is imaginary. Thus, there are no real roots or solutions. So, let's review some terms. Perfect square is a number that is obtained by multiplying an integer by itself. For example, the number 25 is a perfect square since 5 times 5 is 25. And -5 times -5 is also 25. Can you think of other perfect square numbers? Comment it down. Another term is solution. A number x is a solution of the quadratic equation if it satisfies the equation rx² plus bx plus c equals 0. This is called a root of the quadratic equation. For example, in a quadratic equation x² minus 1 equals 0, x equals 1 is a solution since 1² minus 1 equals 0 is true. Quadratic equations that can be written in the form x² equals k can be solved by applying the following properties. If k is greater than 0, then x² equals k has two real solutions or roots. Thus, x is equal to positive, negative square root of k. If k is equal to 0, then x² equals k has one real solution or root. That is x is equal to 0. If k is less than 0, then x² equals k has no real solutions or roots. Let's try these properties with examples. What are the solutions if x² minus 121 equals 0? Here is the solution. To determine the solution of the quadratic equation x² minus 121 equals 0, follow the steps below. Step 1. Isolate a constant on one side of the equation. By addition property of equality, add 121 to both sides of the equation. From the given x² minus 121 equals 0, we now get x² minus 121 plus 121 equals 0 plus 121. We then get x² equals 121. Step 2. Extract the square roots on both sides of the equation. Do not forget the positive, negative symbol in getting the square root of the constant. We now take the square root of x² equals positive negative square root of 121. Step 3. Solve for the values of the variable x. The square root of 121 is 11. Therefore, the solutions are 11 and -11. Let's have another example. Find the solutions of the equation x squared minus 16 equals 0 by extracting the square roots. First we write the given equation in the form x squared equals k. That is x squared equals 16. Second, we now apply the square root property. Considering that k is greater than 0, we will have the positive negative square root of k. Take the square root of x squared. Then the positive negative square root of 16. We get positive 4 and negative 4 as solutions of the equation. To double check, given the values of x, substitute the solutions in the original equation. Both values of x satisfy the given equation. So the equation x squared minus 16 equals 0 is true when x is equal to 4 and x is equal to negative 4. Next example. Find the solution or solutions of 3x squared minus 27 equals 0. First, we write the given equation in the form x squared equals k. That is 3x squared equals 27. Second, simplify the equation by dividing both sides by 3. Or multiplying both sides by 1/3 using multiplication property of equality. We now have x squared equals 9. Third, apply the square root property. Considering that k is greater than 0, we will get the positive negative square root of k. Take the square root of x squared. Then the positive negative square root of 9. We get positive 3 and negative 3 as solutions of the equation. To double check, check the obtained values of x against the original equation. Both values of x satisfy the given equation. So the equation 3x squared minus 27 equals 0 is true when x is equal to 3 and x is equal to negative 3. Next, determine the solutions of x squared plus 11 equals 35. Here is the solution. Step 1. Isolate the constant on one side of the equation. By addition, property of equality, add negative 11 to both sides of the equation. From the given x squared plus 11 equals 35. We now get x squared plus 11 plus negative 11 equals 35 plus negative 11. We then get x squared equals 24. Step 2. Extract the square roots on both sides of the equation. Do not forget the positive negative symbol in getting the square root of the constant considering that k is greater than 0. We now take the square root of x squared equals positive negative square root of 24. Step 3. Solve for the values of the variable x. Since 24 is not a perfect square, we need to factor it such that one of the factors is a perfect square. We have 4 times 6, where 4 is a perfect square. Since 4 is a perfect square, we may take its square root, which is 2, so we get positive negative 2 square root of 6. Thus, the solutions are 2 square root of 6 and negative 2 square root of 6. Another example. Find the solutions of the equation x squared minus 26 equals 6 by extracting the square roots. First we write the given equation in the form x squared equals k. That is x squared minus 26 equals 6. Then, x squared equals 26 plus 6 which is 32. Second, we now apply the square root property, considering that k is greater than 0. We will have the positive negative square root of k. Take the square root of x squared. Then the positive negative square root of 32. Since 32 is not a perfect square, we need to factor it such that one of the factors is a perfect square. We have 16 times 2, where 16 is a perfect square. Since 16 is a perfect square, we may take its square root, which is 4. So we get positive negative 4 square root of 2. Thus, the solutions are 4 square root of 2 and negative 4 square root of 2. Another example. Solve the equation r squared equals 0. Since the equation is r squared equals 0, then the equation has only one solution. Second property. That is, square root of r squared equals square root of 0. We get r equals 0. To check, we can see that 0 satisfies the equation. Thus, the equation r squared equals 0 has one solution. That is r is equal to 0. Solve the equation. D squared plus 1 equals 1. Rewrite the equation in the form x squared equals k. By addition property of equality, we get d squared equals 0, since 1 minus 1 equals 0. We then take the square roots of both sides. Square root of d squared is d and square root of 0 is 0. Since the equation is d squared equals 0, then the equation has only one solution. Second property. Another example. Find the roots of the equation s squared plus 9 equals 0. We follow the same process in taking the square roots. We write the equation in the form x squared equals k. So, we get s squared equals negative 9. From here, we take the square roots of both sides. Square root of s squared is s, while square root of negative 9 is square root of negative 9. Remember that if k is less than 0 or negative, then it has no real solutions. Since negative 9 is less than 0, then the equation s squared equals negative 9 has no real solutions or roots. There is no real number when squared gives a product of negative 9. Thus, the equation s squared plus 9 equals 0 has no real solutions or roots. Last example. Find the roots of the equation 2w squared plus 9 equals 5. Write the equation in the form x squared equals k. We have 2w squared equals negative 4. Since 5 minus 9 is negative 4. Simplify both sides by dividing 2, or by multiplying 1/2. We now have w squared equals negative 2. Take the square roots of both sides. We finally get w equals square root of negative 2. Since negative 2 is less than 0, then the equation 2w squared plus 9 equals 5 has no real solutions or roots. There is no real number when squared gives a product of negative 2. How was the session? Did you learn something? Now, I would like to ask you again this question. How would you know if the given quadratic equation can be solved by extracting square roots? I hope that with this session, you already knew when to use extracting the square roots. Let's try to go back to our competency of the day. The learner solves quadratic equations by extracting square roots. Were you able to achieve this? The answer lies on you. I hope you learn new things in this session. Now, for your task. Solve for the values of x using extracting the square root. Number 1. Y squared minus 121 equals 0. Number 2. 4x squared minus 83 equals 17. Number 3. C squared equals 150. Number 4. 10x squared plus 5 equals 5. Number 5. 3w squared minus 9 equals negative 12. For your answers, please use the comment section. And that ends our session for today. Thank you Quipper for the slides used in this presentation. Once again, thank you and happy learning. Don't forget to subscribe and click the notification button to receive updates. This is Sir RP.